Okay, last homework problem. This one comes from the book. There's a graphic that I want to show, so I'm going to switch back and forth between views so I can show you a bigger version of it. So we've got Katie. She's at the county fair, and she's trying this ring the bell attraction. I don't know if anybody's ever done this before, but you have like this mallet, and you want to hit the mallet onto a platform. There's a ball on the platform. Okay, so when you hit this down, bam, the ball's going to go flying up, and you want to try and ring this bell. Okay, and then if you ring the bell, you're super strong, and if you don't, then you're not. You get prizes, maybe, I don't know, but so this whole problem is based off of this ball earth system that's part of this ring the bell game. Okay. So Katie is going to swing the mallet. She gives the ball an upward speed of 8 meters per second. And we want to know, is the ball going to ring the bell? Okay, we're told that the bell is 3 meters from the bottom. So what we really want to know here is the height that the ball is going to reach due to her hitting it and giving it this initial upward speed. Okay. Initially you may be like, this doesn't make any sense in terms of energy, but really what this is a conservation of energy problem. This is our isolated system, and we're going to use what we know about kinetic and gravitational potential energy to solve it. So my initial point is when the ball leaves the ground and it's traveling upward. My final point is when the ball hits the bell. Hopefully, we'll see. We'll see if she, if you're looking at this, you can see the answer already, but we're going to figure out if she actually hits it hard enough for this bell to travel up and this ball to travel up and ding, hit this bell or not. Okay. So we're saying this is an isolated system with mechanical energy conserved. Our initial energies equal our final energies, our sum of those. Okay. So we've got kinetic initial plus gravitational potential initial equals kinetic final plus gravitational potential final. We can go ahead and eliminate a couple of these, and you're going to see that that's the case with a lot of these problems, okay, where one or two of these become zero due to our conditions. So here, our initial gravitational potential energy is going to be zero. We're basically going to call this starting point of the ball an H equals zero. Okay, so the ball's only got kinetic energy. We're taking this initial point as the ball has barely left the ground and is traveling upward. It's kind of like when we looked at projectiles and we got our final velocity was right before we hit the ground. This is similar to that. Okay. So all kinetic energy initially. And then at the top, okay, the ball is going to hit the bell. It's going to pause briefly when it does that. Okay. Again, it's a little like projectiles, and we're going to have a kinetic final of zero. So we're ending with a velocity of zero. So all of our final energy is going to be gravitational potential. So we end up with kinetic energy initial equals gravitational potential energy final. Okay. So then these are two very straightforward equations. We're going to fill them in. 1/2 mv squared equals mgh. And we're solving for h here because we want to know, how high is this ball going to go? Is it going to go at least 3 meters? Because that's how high we have to go to hit the bell. So we've got 1/2. We've got, we can cancel out mass. That's another thing. You don't have the mass of the ball anywhere, but do you need it? Nope, because it's on this side and it's on this side. So we're going to have 1/2 times our initial velocity of 8 meters per second. Okay, that's our starting off point. That's part of our initial kinetic energy. 1/2 times 8 squared equals 9.8, my value for G, times H. That's what I'm solving for. I'll just put this in the calculator quickly. So 8 squared is, 8 squared is 64 times 1/2 gives me 32. And then I divide that by 9.8. And I end up with almost 3.3 meters. So actually, the ball is going to hit the bell, no problem. So she hopefully wins some kind of great prize. I don't know what. When I used to go to the fair, everybody had giant stuffed animals. But that's how we do that one. It looks a little different because it's kind of wordy, and it's also like, what are we really looking for here? So we want to start off by understanding our situation, our system, our physical system, as well as our starting and final points. And then what are we looking for? We're trying to solve for this height that's going to be part of our final gravitational potential value. All right, that's all the homework problems. Yay.